हेलो स्टूडेंट्स। तो स्टार्ट करते हैं इलेक्ट्रोस्टैटिक का टॉपिक, इलेक्ट्रिक डाइपोल एंड इलेक्ट्रिक डाइपोल मोमेंट। तो फर्स्ट थिंग, व्हाट इज इलेक्ट्रिक डाइपोल? दिस इज द डेफिनेशन. Electric dipole is a system of two equal and opposite point charge separated by very small distance called the electric dipole. Look this diagram. These are the 2 point charge. One is minus q, other is plus q, separated by small distance 2l. This system is called the electric dipole. अब इसमें इक्वल एंड अपोजिट होना चाहिए. अगर ये -1 कूलम है तो ये +1 कूलम होगा. अगर ये -2 कूलम है तो +2 कूलम होगा. ऐसा नहीं होगा कि ये -1 हो और ये +2 दिया हो. अपोजिट अनइक्वल नहीं होना चाहिए, बस मैग्नीट्यूड इक्वल हो और साइन डिफरेंट होना चाहिए. नेक्स्ट थिंग इज इलेक्ट्रिक डाइपोल मोमेंट. इलेक्ट्रिक डाइपोल मोमेंट इज अ प्रोडक्ट ऑफ magnitude of any charge and dipole length. What is dipole length? Dipole length is a distance between the 2 point charges and it is denoted by letter small p. So small p is equal to q into 2l. Magnitude लेना है, sign नहीं लगाना है. We will take only the magnitude and the distance between the 2 point charges into 2l. And it is a vector quantity. Direction, the direction is from minus q to plus q, denoted here minus q to plus q. अगर ये डायग्राम ऐसा बनाया जाता, यहाँ प्लस क्यू यहाँ माइनस क्यू, तो ये ऐसे रिप्रेजेंट कर देता माइनस क्यू टू प्लस क्यू. यूनिट, व्हाट इज द यूनिट? सिंस फॉर्मूला ऑफ डाइपोल मोमेंट इज p इक्वल टू q into 2l, सो कूलॉम मीटर. एंड डायमेंशन, व्हाट इज द डायमेंशन ऑफ q? तो हाउ टू फाइंड डायमेंशन ऑफ q? द फॉर्मूला ऑफ q इक्वल टू it. So for the I is current, dimension is A, time t. So put here q into 2l. Dimension of q is A into t and dimension of 2l is a distance, so distance के लिए l आएगा. So overall we can say l t. Next topic है electric field due to electric dipole. So we can calculate the electric field due to dipole at number 1 axial position, number 2 equatorial position. Axial position is also called end-on position and equatorial position is also called broadside position. And what is the meaning of axial position and what is the meaning of the equatorial position? So look here in the diagram. This is the electric dipole, system of two equal and opposite charges separated by small distance 2l. Axial means along the axis. What is the axis? Line joining of the 2 point charges. This is the axis of the dipole. So the axial position means any position on the line joining of the 2 point charges. किसी भी पॉइंट पे कैलकुलेट कर सकते हैं. यहाँ पर, यहाँ पर, यहाँ पर, यहाँ पर, कहीं भी कैलकुलेट करेंगे. ये सारे पॉइंट एक्सियल पॉइंट होंगे, एक्सियल पोजीशंस होंगी. ब्रॉड साइड पोजीशन मींस परपेंडिकुलर बाइसेक्टर. Perpendicular bisector, this is the point O, midpoint of the 2 point charges, line joining of the 2 point charges. Now this is the perpendicular bisector and this is the equatorial position. So at any point we can calculate the electric field. These points are called the equatorial positions. If we calculate, suppose that this is the point P and this is the point Q. This point is called the axial position and this point is called the equatorial position. And if we calculate the electric field at the axial position, we get answer K. K means, this K means 1 upon 4 pi epsilon naught 2p over rq. What is r? R is the distance from the point observation point P to the midpoint of the dipole. And if we calculate the at equatorial position, we get kp over rq. So it is clear the electric field at axial position is just twice the electric field due to equatorial position. And one thing also important, the direction of electric field at the axial position is from minus q to plus q and electric field due to dipole at the equatorial position is from plus q to minus. Students, we calculate electric field at the axial position. First we draw a diagram. This is the dipole, minus q plus q, separated by a small distance 2l. This is the midpoint of the dipole. This is the axial position. We calculate it at any point on the axis, but we are calculating here at P point. P is the observation point where we want to calculate the electric field, and it is situated at distance r from the midpoint of the dipole. So first we calculate electric field due to this minus point charge. We know that the electric field due to point charge, the formula is kq over r square. So we apply k q over distance square. So what is the distance from minus q to observation point? This is r, and this is the midpoint, so it becomes the l. So total distance from the minus q to p is r plus l. R plus l whole square. And what is the direction? And as we know that the direction of electric field for the negative point charge is towards the point charge. This is electric field due to minus point charge towards pole. And then we calculate electric field due to positive point charge, q over distance square. What is the distance? This is total is r, and this is l. So now we get r minus. And what is the direction? We know that the direction of electric field for the positive point charge is away from the point charge. It is clear at the observation point P there are two electric fields. They are directly just opposite. So we subtract, and if we calculate the net electric field, we calculate the vector sum of these two fields, and they are in the line but in the opposite direction, so vector will be the subtraction. It is clear the electric field due to positive point charge must be greater than that of the minus point charge, because this observation point is near to the positive point charge. So substitute the values, k q over r minus l whole square minus k q over r plus l whole square. Now we take common. Now take LCM. Now right here. After solving, after squaring, r square plus l square plus 2rl. Square of the r minus l whole square, r square plus l square minus 2rl. If we multiply the negative sign, then r square and l square will be cut. 2rl here, 2rl here, so now we get a 4rl. So net electric field equal to kq into 4rl upon r minus l, r plus l is the r square minus l square, and this is whole square, equal to k q into 2l into 2r. This is the 4rl. 4rl में से 2 और l ये ले लेना है और 2r अलग कर देना है. मल्टीप्लाई करेंगे तो नाउ वी गेट टू 4rl. ये इसलिए किया क्योंकि p into 2l डाइपोल मोमेंट में कन्वर्ट हो जाता है. Now we get E equal to K, and this is the P dipole moment, P into 2L, write down 2PR upon R square minus L square whole square. This is the final formula. And here is a condition: if R is very greater than from L, then R square minus L square, now write down as R square, approximately equal to R square. So now we get E equal to K 2PR over R square square. So it becomes the R to the power 4 Now R is squared, so now we get K 2D over R cube. And what is the direction? The direction of net field is in the direction of the greater electric field, in the direction of the E plus Q, because it is greater, so direction is minus Q2 plus Q. So direction is minus Q2 plus Q. Students, so electric field due to dipole at the equatorial position, how to find? First we draw the diagram. This is dipole, equal and opposite point charge, separated by a small distance 2L. This is the midpoint of the dipole. This is midpoint, so this is L and this is L. We want to calculate electric field at this point P, situated at distance R. First we calculate electric field due to charge minus Q, then electric field due to charge plus Q. So electric field due to charge minus Q is K Q over distance square, and this distance is, this is perpendicular bisector 90, this is L, this is R, and this is hypotenuse. This will be under root R square plus L square, and this is also under root R square plus L square. And electric field due to minus Q charge is equal to KQ over distance square. Distance square means this square. So under root R square plus L square whole square, we get R square plus L square. In the same way, electric field due to plus Q charge, this answer will be again same, because the answer KQ over R square plus L square. Because distance be same. It is clear E minus Q and E plus Q is same. So you can say this is equal to E. Both are same. Both are have same magnitude. And we draw the direction of electric field at point P due to minus Q charge. It is towards and it is away due to plus Q charge. We resolve E plus Q, E minus Q along x-axis and y-axis. So look here separately. X-axis and this is y-axis. We assume this is theta. This is theta because this is isosceles angle. This will be again theta because of the corresponding angle. This will be theta because of the alternate interior. So resolve E minus Q and E plus Q along x-axis and y-axis. Along y-axis we get E sin theta and this is E cos theta. Again resolve E plus Q along y-axis, E sin theta, and this is E cos theta. So it is clear the net electric field in the y direction will be, they will cancel out each other. Why they cancel out each other? Because they have the same magnitude in opposite direction. So they cancel out each other and we get a 0. In the x direction, along the x direction, both components are in the same direction, they will be added. So now we get the 2e cos theta. If we substitute a value, 2e is, both are same, e is this k q over r square plus l square into, this is cos theta. What is cos theta? Base upon hypotenuse, means L upon under root r square plus l square. So L upon under root r square plus l square. Root means power 1 by 2. If we solve, we know that electric dipole moment is a q into 2l. So this q into 2l. So it 2ql is converted into p. So we get k p upon r square plus l square to the power. This power is 1 and this power is 1 by 2. Base is same, so power will be added. So 1 plus 1 by 2, we get 3 by 2. And this is the result. Net electric field due to the equatorial position. If we apply the condition, if R is very greater than from L and this distance, this P point is very large compared to the dipole length, then in the place of r square plus l square, we put only r square. So now substitute here, electric field K P over r square to the power, इसके प्लेस पे r square हुआ and power हुआ 3/2, and this square will be cut. So now we get K P over r to the power 3. This is the final result. And what is the direction of electric field at the equatorial position? If these two components are added, this gives the result, and this direction is in this direction, net. So this is opposite to the dipole moment, plus Q2 minus Q. So direction is plus Q2 minus Q.